Today we will be looking at equations of parabolas whose vertices are not on the origin. Now remember that the first parabola you ever saw had the equation y equals x squared. So that was a good old-fashioned parabola that was upward facing. So when you see x squared, like y equals x squared, you should be thinking, oh, that's a normal parabola. If we had a negative sign on it, that just turned it upside down. So when the x is squared, it's either going to be up or down depending on the sign. Now these days we are writing the equations with the squared term first. So you might see x squared is equal to y, and whoops, not squared, and there might be a number in front of here or something. So these were the equations of parabolas that were at vertex at the origin, because here's what they look like when they're not at the origin. Okay, so for example, if I have x minus h squared, and I'm going to say is equal to 4p times y minus k not squared. Now this is still going to be a parabola that is facing up or down, but unless h and k are 0, this is going to be a parabola that's floating around elsewhere, not at the origin. But the vertex is going to be h comma k. So it'll be the opposite of this and the opposite of that. So again, when the x term is squared, it's a normal up or down parabola. But watch out, because sometimes you'll have stuff like this where you'll have y minus k squared is equal to 4p, and then you'll have your x minus h not squared. When your y term is squared, then that means that you're going to have a sideways parabola. Okay, so the parabola might look like this. Okay, or something. So anyway, for problem number 1 and 2, we are supposed to write the standard equation for each parabola below. Alright, first thing you always have to do is decide, will the x be squared or will the y be squared? So since this is a normal upward facing parabola, I'm going to do it so that my x is squared like normal. So I'm thinking, x minus h squared is equal to 4p y minus k not squared. Now I know the vertex is 3 comma negative 1, so that makes this become x minus 3 squared, alright, is equal to 4p, and then it'll be y plus 1 not squared. Alright, it's the opposite of these. Positive 3 becomes negative 3. Negative 1 becomes plus 1. Alright, so all I need is to know the p-value, and then I'll be able to fill that in and be done. Alright, remember that the p-value is the distance between the vertex and the directrix. Now this is a very tight, very close difference, but we can use the coordinates to help us out. See, the y value of the vertex is negative 1, and then the y value of the directrix, alright, the entire equation, is negative 5 over 4. So what's the difference between these two? So I'm just going to subtract them. Negative 5 over 4 minus negative 1. Okay, so that is a difference of negative 1/4. Alright, so concentrate on the absolute value here. So p is 1/4. Now if I substitute 1/4 in for p, then what happens? I've got 4p becomes 4 times 1/4. But 4 times a fourth is equal to 1. So 4p has a value of 1. So really this equation is going to become x minus 3 squared is equal to 1 times y plus 1. So there won't be a visible number out front because it's a 1. But that is the equation of this parabola. Alright, problem number 2. Here's our thought process. We see that it is sideways. That lets us know that it's going to be one of the ones with the y squared. We see the vertex. The vertex is the point -1, 0. So the -1 is going to give us the x value, except it will be opposite, so +1. The 0 goes here for the y value, but that means we're going to wind up just putting y squared, because y plus 0 is just y. So really it's just y squared. Alright, so this is what we have so far. Now the p-value is the distance from the vertex to the focus. Okay, so the p-value is 1. So if we plug in 1, then that's going to give us y squared is equal to 4 times x plus 1. Now, does this need a negative sign on it? No, it's going to the right. That's the positive direction. So this is going to be the equation for this parabola. Also notice that the focal width right here was 4. Alright, so we were expecting to see a 4 right there anyway. That's another way to think about it.